Did you know that our Sun, along with our whole galaxy, rotates around the centre of the Milky Way? Hi folks, and thank you for joining me once again on Rico's Nature Realm. My name is Rico, and on this channel I'll be exploring natural phenomena. So let's buckle in, and I hope you enjoy the journey. The name Sun originates from the Old English spelling sun, which has an NE at the end. The ancient Greeks called it Ilios, after the son of the Titan Hyperion and Thea. In ancient Rome, the sun was also known as Sol, Latin for sun. For the ancient Egyptians, the sun took the form of a god named Ra. The sun has a large effect on our planet. It drives weather, ocean currents, seasons, and our climates, also making plant life possible through photosynthesis. This is a process where plants and certain other organisms transform the energy received by the rays of the sun into a chemical energy. Within this process they are able to convert water, carbon dioxide and minerals into oxygen and energy-rich compounds. Without the heat and the light from the sun, we would not have life on Earth. Our sun is one of 100 billion stars in our Milky Way galaxy. Scientists are estimating that the sun to be approximately 4.5 billion years old. We cannot measure the sun directly, and it is not possible. We have to use indirect methods to check its age. Our galaxy being formed around the same time, so we can look at the oldest object we can find and from this ascertain the age of the local galaxy and the formation of our sun. Every planet star has its own classification. Our sun's classification is known as a G2V star. This means that it is a dwarf star that converts hydrogen to helium at its core via nuclear fusion. G-type stars fusing hydrogen for roughly 10 billion years, at the end expanding to a red giant. This means our 4.5 billion year old sun is around halfway through its life cycle. When it expands into a red giant, the sun will become 2,000 times brighter, increasing its size. If anyone is left on Earth when this happens, they'll be engulfed by its inferno. When light emanates from the sun, it travels at 186,287 miles per second, or 299,792 kilometers per second, taking 8.3 minutes for the light to cross 93 million miles, or just over 149.5 million kilometers to reach Earth from the sun. The sun has a radius of 696,340 kilometers. That's 432,685 miles, with a diameter of 1.39 million kilometers, or 864,000 miles. This is like placing 109 Earthers side by side. The Earth can fit in the sun 1.3 million times. The sun is composed of two different gases. Reacting with one another, they are hydrogen at 70% and helium of 28%. Carbon, nitrogen and oxygen make up 1.5%, and the other 0.5% is made up of small amounts of many other metal elements such as neon, iron, silicon, magnesium and sulfur. The sun is made up of several layers. This is broken further into two main sections. Starting at its centre, there are the interior layers, with the atmospheric layers on the outside. The sun's journey starts at its core. The core is the innermost layer of the sun, being 195,000 miles or 313,822 kilometres thick. This is like driving from New York to Los Angeles 70 times. With so much weight within the sun's core, it has a density of about 150 times greater than being in deep ocean. This pressure causes the hydrogen atoms to smash together with such great force they create helium, where they become unstable, releasing nuclear energy. This process is called nuclear fusion. This is what keeps the sun alive. The temperature at its core is about 15 million degrees Celsius or 27 million degrees Fahrenheit. This is hot enough to melt iron, brass and even lead. Surrounding the core is a radiative zone, where the nuclear energy produced in the core is transferred outwards in the form of electromagnetic radiation. This is better known as light. The radiative zone is 186,965 miles or 300,000 kilometers across. This is the same distance that light can travel in about a second. Being still very dense, photons of light bounce around repeatedly, absorbing and re-emitting, slowly making their way towards the outer layers. A bit like a pinball machine. The beam of light can take about 100,600 years to make its way out of the radiative zone. The temperature here ranges from 2 to 7 million degrees Celsius, or 3.6 to 12.6 million degrees Fahrenheit. Above the radiative zone is known as a convective zone. This area spans 124,000 miles, or 201,168 kilometres. Density is reduced enough for light to start to form heat. The temperature in this convective zone can reach 2 million degrees Celsius, or 3.6 million degrees Fahrenheit. In this layer, the process of convection occurs. This means that the hotter materials will rise. As they rise, they begin to cool and will sink. This process occurs with giant bubbles. These are called convection cells. This is the same process as you can see in a boiling pot of water. Moving outwards, we reach the photosphere layer. This is the first of the atmospheric layers. The word photosphere has its origin from the Greek words meaning light sphere. It is where visible light first appears on the sun. The photosphere has a temperature of about 6,000 to 11,000 degrees Fahrenheit, or 3,315 degrees to 6,093 degrees centigrade. This is a layer of the sun that creates the sunspots that appear on the surface of the sun. This causes the surface of the sun to appear grainy. The photosphere is the visible surface of the sun and a layer from which most of the sun's light is emitted. Above the photosphere lies the chromosphere. It's a layer that's about 2,000 to 3,000 kilometres thick. Its name has its Greek origins, meaning colour sphere. The temperature of the chromosphere is around 6,700 to 14,000 degrees Fahrenheit, or 3,700 to 7,700 degrees Celsius. At this temperature, hydrogen burns, giving it off a reddish colour. The outermost layer of the sun is known as a corona. This is Latin for the word crown. This is the hottest layer at around about 2 million degrees Fahrenheit, or just over 1.1 million degrees Celsius. At this level, hydrogen is stripped of their electrodes, leaving a bare nucleus. The magnetic field lines at this level trap hot plasma, forming spike-like shapes called streamers. These are not the same as the party streamers that we're using on an espresso party, but these appear giving the sun its crown-like shape. The corona is also the cause of the northern lights on Earth. When the plasma flows out of this level into space, some of it reaches Earth's atmosphere, mixing in with atoms and molecules, reacting and causing the colours that we see. Each of these layers plays a crucial role in the sun's structure and the way it emits energy into the solar system. Have you ever heard of a solar storm? These can be broken down into two categories: a coronal mass injection or a solar flare. These are both explosions that can occur on the sun, sometimes occurring together. This is a result of large amounts of magnetic energy building up in the upper atmosphere of the sun. This energy is released when an intense burst of either ultraviolet, electromagnetic, X-ray or radio wave radiation occurs. A coronal mass injection is also referred to as a CME. It is a huge cloud of solar plasma, charged particles and magnetic field injected into space. This is caused when magnetic fields on the sun, when they become twisted and they snap, launching the plasma. It is slower moving than a solar flare, taking about 1 to 3 days to reach Earth. It can affect the Earth with geomagnetic storms, which can lead to auroras. These are the northern and southern lights, disrupting satellites, and they can affect power grids. A solar flare is a sudden intense burst of radiation from the sun's surface. It is caused by magnetic energy build-up in the sun's atmosphere suddenly being released. The radiation travels at the speed of light, reaching Earth in about 8 minutes. It can disrupt radio communications, GPS and power grids. The simplest difference, a solar flare is like a flash of lightning, bright and fast, whereas CME is like a cannonball, slow moving but significant impact. The first solar flare was witnessed on the 1st of September 1859. When we compare a yellow sun to the rest of the suns within the galaxy, a yellow sun is both on the medium side as well as the cooler side. The hotter Rigel sun burning a blue in colour, with a Betelgeuse star that burns orange in colour. This makes up around about 80% of the stars in our galaxy. Our planet Earth, along with the other 7 planets that rotate around the sun at the same time, the sun moves around the Milky Way, taking approximately 226 million years to do a full rotation. With the dinosaurs going extinct about 65 million years ago, we still not have completed a rotation since then. The Sun is made up of sections and rotates at different speeds. The equator taking around about 25 days to complete a rotation, with the North and South poles moving slower, taking 35 days to complete their own rotation. The Sun's gravity is 27.9 times stronger than that of Earth. The Sun is under enormous amounts of pressure. Hydrogen atoms are constantly colliding with one another within the Sun, creating helium-releasing energy. In 1 second, it releases 118 trillion times more energy than America used in all of 2003. The Sun has an 11-year solar cycle. During this time, there are periods of higher solar activity. The release of energy is accompanied by massive explosions of plasma, a hot ionized gas made up of electrons and ions. That's it from me, folks. Thank you for joining me, and I'll see you on the next episode.